Hello and welcome back to the channel. My name is Piyush. This is day 7 in 30 days of AWS Terraform, and this video will be looking into very important concept which is type constraints in Terraform, and we'll be looking into all those type constraints that we have with the help of examples, with the help of an end-to-end demo. So let's get started with it. Okay, so let's understand all the type of variables that we'll be covering in this video. So we have two type of variables on like at the broader level. One is based on purpose and based on values. So based on purpose we have already covered. So we have input variable, output variables and local variables. But then we have based on value, and these are also called type constraint, meaning the type of value that we store in a variable, it defines the type of variable it is. So we have two major categorization of this. One is primitive and another one is complex. Primitives are the simple, straightforward that you have been using all the time. So string, number and boolean. Strings such as, let's say an example of string which is, let's call it name and Piyush. Okay, let me just increase the font size over here. Okay, so name equal to Piyush. This is an example of a string. String could also have spaces. So instead of name, we can have full underscore name is equal to Piyush space 𝗏𝗏. But how would it take the value? We have to enclose the value in double quotes, and that double quotes represent that value is a string. Okay, so this is how we initialize the value of a string variable. Now we also have number. Okay, so number is something, let's say age. So you can just enter the age. Age is 35 something, So that's of type number. And then we have boolean or bool. So bool is something which is either true or false. So let's say is adult. Okay, and the value is yes. Okay, something like that. So here are two example of strings. This is number and this is bool. So this is all primitive type. Now we have complex type. Complex type, if I explain it right now, you will get confused. So it's better if we explain it while doing the demo. But just understand, like complex will have multiple values. So over here, we are storing one value in the variable, but in all the complex type, we'll have multiple values, and each of these have a separate purpose. Like list will be used in certain cases, set will be used in certain cases, map, object, tuple, everything will be used in certain cases. And then we have special type of variable which is null. Null meaning we can store null values as well. That means the variable value can be null. That could be empty, right? Something that we don't store. It just reserves the space in the memory, but it does not have any value. I mean, we'll possibly look into example later on, like the example of null. And then if we don't set anything, it would take the data type as any. Okay, so we'll be doing a demo now of all of these data types. So stay with me, and at the end of this video, you will understand each and every variables that we have, each and every type constraints, whatever you want to call it. So, but just stay till the end. It could be a long video, but just have some patience because I will be making some mistakes so that I will make you understand what could happen if we specify something that is not intended. Okay, so we'll be doing that. So let's start with the demo. Okay, so here's my VS Code, and I believe this is visible. Now what I'm gonna do is I'm gonna make a copy of day 6 folder so that we can make the changes in that. I hope you have been following this series from the sequence from day 0. In day 0, I have shared the details about 30 days of AWS Terraform challenge, how to do the submission, how to participate in challenge and so on. And I have shared more details about it. If you have not watched it, go ahead, watch that video and then come back to this. Or I would prefer and I would recommend watching the series in the same sequence so that you don't miss any concept. Okay, if you have done that, then it's well and good. Let's follow ahead. So what I'm gonna do is I'm gonna why I'm getting okay. let's go ahead in this folder. I'm just gonna go in this folder over here. This is day 4, day 3. Okay, let's go over here, open in terminal. Okay, okay, now what I'm gonna do is I'm gonna make a copy of this folder, which is day 06, and I'm gonna make it day 07. All right, it's done. Now we have a folder called day 07 with all the files, and we will be making all the changes in this day 7 folder file. Okay, so let me first close all the files over here so that I accidentally don't make any changes in any other folder. Okay, now we are in day 7, which is over here. Let's go to main.tf. Okay, so we'll be looking into all those type constraint one by one. So let's start with the first one, which is number. Okay, so in number, let's remove this S3 bucket and let's remove this VPC as well. We'll just start with basic. We'll start with AWS instance and we'll create some security group rules in this as well. Okay, so over here, do we have any number that we have used? No. So let's go back to the Terraform documentation over here. And this is for AWS instance. And let's go down and see if we can add. Okay, first let's add over here. Let's say in AWS instance, we have these two that we can use. Okay, and we'll look for more. Okay, and let's see. So basically we are looking for any data type that is of type number so that I can try fit that in the Terraform file itself. Okay, so okay, so let's do one thing. Over here we can add one value, which is count. Okay, count is optional and you can add it in multiple resources. Count is basically when we have to iterate it through values. So for now, we'll just keep count as 1. Okay, so we have kept count as 1 and let's just try to run Terraform in it. Let me set the alias as well. Alias tf is equal to Terraform. Okay, and tf init now. I'm not in correct directory, so let's go inside day 07 and run tf init again. Okay, now it has initialized the backend and it should be the remote backend because we have our backend.tf file over here. So let's quickly check initializing the backend, and it doesn't say anything about that. I mean, it should be good. So let's run tf plan. Okay, it says missing resource instance key, which is AWS instance.example.id. Okay, because AWS instance.example.id, because we have not provided the count value in the output variable. Okay, so if we see the output variable, we have just specified AWS instance example.id. But now that we have specified count, that means it is expecting multiple values. So it should be like count.index. We have not covered this yet, so I'm not gonna add it over here. Instead, what I'm gonna do is remove this output.tf file. Okay. So don't worry, if you have some confusion, it will be solved later on when we cover count.index and all those meta arguments. It's not covered in this video. That's why I've removed output. I'll be keeping things simple. Okay, and we'll go step by step like how I promised earlier. Okay, so now let's run tf plan again. Okay, now it says one plan to add, and here are all the details. Count equal to 1 because we are creating one instance. When we had to create multiple instances of the same values, we can add count equal to 2 and we can iterate it through values. I'll show you later on how do we do that. But for now, This is what we are doing. And now, as we have seen, we have initialized count equal to 1. So what we can do instead of this, we can create a variable. Let's go inside variables.tf. Okay, and over here let's declare a variable and instance count. Okay, type equal to number. Even if you don't specify the type, it will automatically create a type with any. That means you can provide any values, and whatever value you provide, it will select the type of that variable. But you can specify the type and default equal to 1. You can do that, or what you can do is remove it from here and specify that in terraform.tfvar file. Okay, so you can also mention it over here. Let's add it 1. Now in your main.tf, instead of count equal to 1, you can do var dot instance count. Okay, so that's how you can create a variable and you can use a variable. Now we have used a variable of type number, because count is expecting number format, like not in ABCD alphanumeric format or any other format. Count is expecting a number format. So that's what we have specified in the variable type. So variable, it has multiple other fields, but important fields are description and type. Okay, so we have specified instance count as number. So that was the first type constraint. Okay, the second one is string. String is again a common one. So let's see what string we can use. Maybe let's add one more tag over here and let's call it, or yeah. So for string, let's do one thing. So we already have this region, right? Region var.region, which we have created the variable earlier. So go to variables.tf, search for region, and if we select the type as string, that would just do it, right? So this is of type string. We can have multiple other, like this is also a string, this is also a string. You can set the type string over here as well. And channel name, I don't think we are using it anymore because we are not using the S3 bucket. It was for the S3 bucket, so let's remove this. Right, so we have now two string and one number. It is throwing error locals.tf because it might have the reference of that channel name right over here, you see. So we can remove this local as well. We don't have the bucket anymore. Okay, now if we run the tf plan again, it should not make any changes because we have not added more resources. We have just provided the variable type. Okay, so it's basically showing the same thing. Now the third type constraint is boolean. Okay, boolean or bool. Boolean which returns either true or false. Okay, so what do we mean by that? It checks a statement. If it is true, then it returns true. If it is false, then it returns false. I will explain it to you what will happen. Okay, so we don't have any boolean data type over here. Let's go back to the Terraform documentation and maybe over here in the argument section, search for monitoring. Maybe we'll check if the monitoring enablement required or not. So we'll check a couple of arguments over here, which is monitoring. Okay, so monitoring is of type boolean, as if you can see over here it says if true, the launch EC2 instance will have detailed monitoring enabled. So if true, that means it's of a type boolean. If you want to confirm, you can click on that, and I mean it doesn't have any further field, so that's fine. But yeah, so this should be boolean. So let's add this monitoring, and let's add one more, which is associate public IP. Where it is, let me just search it. Associate public IP address. Okay, because this is asking a question whether to associate a public IP within instance in a VPC. So whenever there is a question, that means it is expecting either true or false, right? So that's why this is also boolean. So let's add these two fields in our EC2 instance. Okay, so the first is monitoring. Okay, and when you type monitoring, it will also show you the type. If you have that GitHub Copilot enabled, it will show you the type of value it is expecting. So let's say true, and associate public IP. And if you see, this is also highlighting optional, and data type is Boolean over here, right? So associate public IP address is equal to true. Now, instead of hard coding value over here, because we are using variables to simplify the things to make the code manageable, let's add it as a variable. Okay, so again, go to variables.tf. Let's add variable, and then the name of the variable was monitoring. So monitoring enabled. Default, you can add it over here if you want. So let's add it over here instead of tf_var, and the type is bool. Okay, that means it is expecting either true or false. The next variable is for the second thing, which is associate public IP. So associate public IP, and again, type is bool. Okay, default is true. So let's add it over here, and let's go back to main.tf, and instead of this, we can add var.monitoring enabled and var.associate public IP. You see over here, the variable name and type is almost similar. I mean, you can have it same as well if you want, but it will take the value from the variable. So now monitoring will be var.monitoring enabled. var.monitoring enabled, which is a variable, and the value of that variable is true. So monitoring will become true. Associate public IP address will become true. Okay. So now if I run Terraform plan over here, now it should show the plan with two additional fields, monitoring and the public IP enabled. Let's see over here. Okay, here it is. Monitoring is true, and associate public IP address is also true. Okay, so that was the third type constraint, which is Boolean. Now the next type constraint is list. For that, let's do one thing. Let's add one more resource. Let's add security group as well. Okay, so let's go to the Terraform documentation and search for AWS EC2 security group over here. If it's not in the EC2 section, then it will be something else. So let's search for security_group. Now it is part of VPC resource. So let's go over here and let's copy the sample rule. Okay, so security group rule allow TLS. Let's pick a simple one. Do we have any other? Okay, that is fine. Let's pick this one. So what it is doing, allow TLS, it is allowing TLS inbound traffic and all outbound traffic. So it is allowing inbound traffic on port 443 to port 443, and also it is allowing it for IPv4 and IPv6, and it is allowing egress traffic on all the like 0.0.0.0, like to everything. Okay, so let's copy this and let's go ahead. I'm gonna paste it over here. Now we'll make the changes over here. Okay, so we don't have a VPC, so VPC ID will be like, let's remove this because we have not created the VPC, so we want VPC to be auto detected. Okay, so let's skip this field. We don't want VPC ID to be created from the Terraform, like it will use the default VPC. Okay, now security group allow TLS, this is fine. Tags will update it later on. Okay, now security group ID equal to AWS security group, which is this resource over here, dot allow TLS, which is the name, dot ID. Okay, because first resource that we have created is security group, Then we'll be creating security group rules. Security group rules itself is a separate resource. Okay. So first resource is AWS security group ingress rule, and then we have egress rule. Okay. So ingress rule for IPv4. So this is what we have used from port. Now from port to port, you can again have it as a number, or I will show you one more thing. The same way it is for IPv4, IPv6, and the same way you have it for egress as well. Now the CIDR over here, we need to make changes over here as well because we don't have the VPC created. So let's add a CIDR block, and let's add something. Okay, so what we can do is we can just keep it blank for now. Okay, and let's make the changes later. So CIDR IPv6. Actually, let's remove the IPv6 rule for now. And the same way, I'm gonna remove the egress as well for IPv6. Okay, now we have CIDR IPv4 and CIDR IPv4 over here as well. Okay, so let's say we have to add multiple CIDR blocks over here. Okay, so we are allowing TLS from multiple CIDR blocks. What we can do is we can create a new variable. Let's go inside variables and variable, and let's call it CIDR block. And this time I'm not gonna select one type of variable, right? What I will do is I will select multiple blocks. So I will put that inside square brackets. Okay, and I will add multiple blocks. So for example, one that I've added 10.0.0.0/16. I can add another one which is 192.168.0.0/16, and I can add another one which is 172.16, okay, /12, and this we can change it to /8. Okay, now this cannot be of type string. Why? Because you see, it's not a single string now. It is multiple strings. It is a combination of multiple strings. Right? This is one string, comma, second string, comma, third string. So what it is a list of strings. So that means the data type is list. So how we can specify the data type? We can just write list, and in brackets we can write string. So this can be a list of numbers. This can be a list of string, right? It could have multiple values, but the data type has to be same. If it is a string, then all of the strings should be there. If it is a number, then all of the elements of the list should be numbered. Now, how do we access the element? So these are different elements of the list. Like this is how array works as well. But if you don't know array, so basically list start from the 0th element. Okay, so let's say there are 3 elements, okay, over here. Okay, so let me just put it one in a line. Now if I want to access first element, then it would be at index 0. If I want to access second element, it would be at index 1, and this would be index 2. So if we have 3 elements, that means it will go from 0, 1, 2. So these are 3. List always start with 0 index. Okay, I will show you how do we access it now. Okay, so that's one thing. So that's a list of string. If we go to main.tf, and now we have to provide the CIDR IPv4. So what we can do is var.CIDR block. Okay, and let's say if we want to access the first element, so what we can do is CIDR_block, and in square brackets we can enter the index of the element. Index is, let's say, 0. 0th index will be the first element. So if I do that, and yeah, let's keep it the same way, and if I run 𝗃𝗏plan, so let's see the value that it will have for the CIDR block. Okay, now it says 4 plan to add because we added 1 security group and 2 security group rules as well. So 3 additional resources will be created. Now let's see the CIDR IPv4, which is 10.0.0./8. And if we go to our variables and if we check this, this was the first element. Okay, because we have selected 0th element. Now if we go back again and if we select instead of 0th, if we select second, so it will use the third element. Okay, let's check this out. Run 𝗃𝗏plan again. And what was the third element? Let's see. The third element was 172.16, right? So let's go over here. You see 172.16. And if we want all the elements of the list to be included, so for that, what we need to do is vad.cidr block, and we can just remove this. Or I think we cannot remove it. Let's see if we can just add star. Okay, and let's run 𝗃𝗏plan again. Okay, now it is throwing the error because it's a list of string. Okay, so let's remove this part and let's run 𝗃𝗏plan again. Okay, it is expecting the element. I might have made a mistake over here because ideally this should have worked. Let's go to variables.tf. This is list of string and these are all the allowed values. It says no declaration found for var.cidr block. Let's go and quickly check the documentation, what we are doing wrong. Okay, so we have CIDR IPv4 and let's check its valid values for CIDR IPv4. Okay, there is like argument is not specified because it's part of ingress rule. So if we go to ingress rule over here, now this is the CIDR IPv4 and CIDR IPv4, the source IPv4 range. I think it is expecting just one value, one CIDR range. What if we want to add multiple CIDR range? So let's see if it has any other. I think we can add that in security group itself. Instead of separate ingress and egress rule, if we add one security group rule like this and specify type equal to ingress, then we can have CIDR blocks. Okay. Now CIDR blocks. So yes, this CIDR blocks can have list of CIDR blocks. Okay. So either we can do that, either we can replace that ingress or egress rule with just one security group rule that has ingress and that has egress. Like instead of having different type of security group rule, we can have AWS security group rule, one of type ingress, other of type egress. So we can do that, or we can just use the existing one and instead of specifying the entire, we can just select the element, let's say 0th. Okay, and the same way over here, let's keep it the way it is. Now if we save this and run the 𝗃𝗏plan again, it should resolve the issue. I hope you understood what we have done. So now it is taking the 0th element because this particular value should be of type string and it is not expecting, you see over here it says string, it is not expecting a list, right? If you want to use a list, you have to use a different resource type, which is AWS 𝗵𝗔 security group rule instead of ingress rule. Okay, now we can use one more list over here to showcase. Let's see where we can use it. Okay, let's say instance type. If we don't want to specify T2 micro over here, right? So what we can do is we can create one more variable and let's call it variable allowed VM. Okay, so list of allowed VM or allowed, what we can do is allowed VM type. Okay, this is more realistic. Okay, now we can have this allowed VM type variable created again of type list of string, and we can add some values over here. So T2 micro, T2 small, T3 micro, T3 small, and so on. Right now in our main.tf, instead of hard coding the value again, what we can do is var dot allowed VM types, and we can specify the index, let's say first. Now if we do that and run tf plan again, the variables.tf has first element as in this is 0th and this is first, so it should create T2 small. So let's see the type of VM that it will create. It should be in VM, which is should be up over here. T2 small, instance type is T2 small, which is 0th and first. So first index, second element. Okay, so that was list. Now list, important thing to remember is, okay, maybe I'll explain one more variable type and then I'll tell you one more thing about list. Okay, now you see we have var.region. What if we want to create similar list like allowed VM types and so on, right? So what we can do is we can create one more variables.tf variable allowed region. Okay, why did I use the uppercase? Let's keep the consistent formatting. Allowed region. Okay, and in the allowed region, now instead of list, what we can do is we can create this of data type set of list. Now there is a difference between set and list. Okay, now with set, duplicates are not allowed. So over here you cannot add duplicate. Even if you add duplicate, it will remove automatically. So let's try to add a duplicate string over here. Okay, so I have added the duplicate string. So now 0, 1, 2, 3. Okay, so we have 4 element, but again start with from 0. And let's go back to main.tf, and instead of var.region, we can just write allowed regions, and let's add 0th element. Now it will throw an error and I will tell you why. Okay, let's run tf plan. You see, it says var.allowed region is a set of string. Element of the string are identified only by their value and don't have any separate index or key. So it is only possible to perform operations on all elements of the set, right? So because it's a set of string, you cannot access it by their index. Now if you want to do that, if you want to access it by their index, you have to convert it to a list. Okay, so for that, what we need to do is you need to add a function called toList and enclose everything inside that function. Okay, we have not covered the function yet, but this is important to showcase how set works. For now, just remember this thing, and when I will explain the function, I'll explain everything in detail. For now, just understand this thing. Whenever we have to access a particular element of the set, then we need to convert it into a list first. We cannot access set directly with the index. Okay, now if you run the tf plan again, it should work. Oh, it says element are identified only by their values, blah blah blah. But I just converted that to a list. Invalid index. Okay, So if we go to variables, I think over here, yeah, that's the mistake. So this element should be outside the bracket like this. Why? Because first we have to convert the value of allowed region, like the entire value of the list of the set to the list. So this is var.allowed region, it will return the entire value, right? And that's how you can convert it to list. Now it should be able to return the value of 0th element. So let's run tfplan now. Okay, now it worked. And if you check the value of allowed region, which region did it select? Which is US East 1. US East 1 was the 0th element. Okay, now it can take duplicate as well, you see, because list can have duplicate elements, set cannot have duplicate elements. Now how do we use set without converting it to a list? Okay, for that you cannot have, for example, let's say, okay, we took this as a set of, oh sorry, a list of string, right? So let's convert that into set of string. Now because we needed all the values, so if we convert that to set of list and go back to main.tf and over here CIDR, where it is, okay, over here. So if we remove this CIDR block, would it work? Let's check out. It says is a set of string. It says inappropriate value for attribute CIDR string required, but have set of string. It says incorrect value of type. Now if I add the element over here, let's see if it's gonna work. tfplan. Okay, it says the elements of set are identified only by their values and it does not have any index. So with set we cannot have it accessed by their index. That's an important thing to understand. Why? Because it's a set, it's not a list. Although it looks like a list, but it's a set, it's not a list. So we cannot access it with the element like this. Okay, we have to only use the values. So how do we use the values? We have to first convert that into a list and then we can use it, because it can have duplicate values, you see. So if we have duplicate value, how would it differentiate between the indexes, right? I mean, index 2 and index 3 could have same value. So that's why this is not something that you can do. Okay, so over here, let's keep it the way it is and let's change this to list again. Okay, so that was set. So we have covered number, string, boolean, list and set. Now the next one is map. How do we use a map? So let's go back over here and pick something, let's say tags. Okay, so tag has multiple values. If you remember in previous videos, I've told you like this is a different data type. Okay, and I did not explain what type of data type it is, which type constraint it is, but I just said that I will explain it to you later. So now is the time when I'm going to explain it. So as you see, this tag variable has multiple keys and multiple values. So it's in the form of key value pair. It's like a JSON and it has multiple key value pair, and we can add more values. Like we have environment, which is var.environment, and then name, which is the resource name, and it has a value. And we can add more things like created by Terraform, right? So we can have multiple key values inside a single variable. So this type of data type is called map. Okay, so instead of having put everything over here, let's copy this and go to variable over here and create a new data type. Let's call it variable and tags. Okay, now tags will have a type. Let's call it type is map of string. Again, the same way we have a list of string, we can have map of string, map of number, and so on, right? So for now we are using map of string, and we can add default value over here or in the terraform.tfr files. So let's add default value over here. So we have added environment, which is derived from var.environment. We have a name, and then we have created by Terraform. Now we don't have to provide everything whenever there is a tag. So what we can do is go to main.tf, and instead of this, tags equal to var.tags, and that's it. So all 3-4 lines have been replaced by this single line. Now if we go over here, so instead of this thing, we can have var.tags. And yeah, I mean, this was just part of this. So now if I run tf plan again, it says variables not allowed. Variable may not be used here because we are using variables inside the variables. Okay, let's go back to variables. Okay, we are interpolating it over here. So that's why it is not letting us do that. We remove this from here. I'm just trying it out, right? Yeah, it is showing me to do that. Variables may not be used here. Variables not allowed. We should have environment variable over here, which is this one. Default value is environment, but I think we cannot use it within this. So what we can do is maybe we can create a local for this name, or yeah, we can create local, right? But for now, let's say if we remove that, now it is throwing errors for the other one. Oh, because it did not, it was there in the double quotes. Okay, so let's keep it simple over here. Let's put environment equal to dev, and name is equal to, let's call it dev instance created by Terraform. Okay, and environment also should be enclosed within double quotes because it's of type string. Now we have a map of multiple strings with key value pair. Now if we go back to main.tf, as you can see, tags equal to var.tags, which is a map of string. And when we run tf plan again, okay, now it says, let's see the value of tags wherever it is, over here, which is all three. Okay, and let's check over here as well. Over here as well, right? So this is tags and tags. All this is, I mean, basically the same thing that is showing multiple times because it's showing the tag of the resource and then tags of all the resources above it. So that's fine. Okay, so we have added tags as well, which is of type map. Okay, so we have covered map as well. Now the next data type is, so there are two more left, which is dictionary and tuple. Tuple or tuple, you can call it anything you want. But the way it works is, tuple is something that can have multiple values and have multiple data type. It is similar to set, but it could have multiple data types. So when we use set over here, right, over here, it has one data type, which is string, but you can have multiple data type inside a tuple. Okay, so let's see how we can use that over here. So for example, we want to, let's say, use some values over here. Okay, from port IP to port, let's copy this. Let's go inside variable and let's call it variable ingress values. Okay, and let's create it of type is equal to tuple. Okay, now we have to specify the values that we want. Okay, so let's say the first value that we want is a number, second value that we want is a string, and the third value that we want is also a number. Now this sequence does matter because the value that we're gonna put, it has to be in the same order. So let's say default is equal to 443, and then there is a string which is TCP, and then there is a number again 443. Okay, so the way it works, it will match the element position, its data type with the value. Okay, so there is number at the first position, so this should be a number. There is string at the second position, this should be a string. There is number at the third position, so this should be a number. So the sequence matters, the data type matters. You can have multiple data types. Yes, you can have number, string, number, and you can have like map inside it, you can have list inside it, but the value should be at the same position. And how do we use that? If you go over here, now instead of 443 port over here, you can use var dot what was the value, ingress values 0, which is 0th element, and this one was var dot ingress value, which is at the second element, and TCP was the first element. So var dot ingress value first element. So this is how you would use the tuple. So let's run the TF plan again just to make sure that we have everything correct. We'll run it, and yeah, everything is good. So you see from port to port should be 443, and IP protocol is TCP 443. Okay, so this is how we use the tuple. Now the last one is dictionary. I'm not sure why I have been calling it dictionary for so long. It's not dictionary, actually it is object. It is of type object. So what it does, it's a collection of multiple data types, but not in the list format. Like the way we have seen is this, right? Tuple have in this format, which is a kind of list of multiple data types. But object, variable, and let's call it config. Okay, and let's add type is equal to object. Okay, now object could have, let's say, region is equal to string. Then we can have monitoring is equal to bool. Then we have instance count is equal to number. So we have used different data types inside the object, but with a key value pair. It's not a type of list, it's a key value pair. It's a type of collection of different elements in a map. If you remember, when we see map was again a key value pair, but they all had single data type, which is defined over here, right? Because it was a map of string. So that's why all the values inside the map has of type string. But over here, because we are not defining the data type of all the elements, instead we are defining the data type of each of the element. So we have said region should be string, monitoring should be boolean, instance count should be number. And now we can have its default value. So let's add default as well. Instance count is, let's say, 1. Monitoring, let's add the suggestion, monitoring true, region is this, and this is how it will look like. Okay, so region is string, so we have added the string over here. Monitoring is bool, so we have added the value of boolean. Instance count is number, so we added 1 over here. Now how do we access this? Let's go back and let's see in the region over here. Okay, so instead of using that set, or let me just comment this and add region is equal to var dot what was the name of it? I believe config dot region. Okay, so this is how it will select the value. So var dot config dot region, which is variables var dot config dot region. Okay, if we go back and if we run the tf plan again, it should work. Okay, it did not throw any error, and it should have selected the region, which is US East 1, that we have configured in the default region. So that's how you can access other values as well. So this is useful when you have to group the common values together. Let's say config of a particular resource or the metadata of a particular resource, and you can access it like how you would access the variable. Again, wherever there is a key value pair, you access it with the key. Okay, so variable name and the key. Wherever there is a list, you access it with the index, like name of the variable dot the index, 0th element, first element, one element. So whenever there is a map, you can access it with key value pair. Whenever there is a set cannot have duplicate values, it will remove automatically, but list can have duplicate values. But you cannot access set with the indexes. You have to convert it to the list first. List can have duplicate value. You see over here, we have T2 micro, T2 small, T3 micro, T3 small. You can add T2 micro again and it will work without any issues. And you can access the list with the indexes because the order is fixed. You cannot change the order. Order is fixed for the list. And then we have Boolean, which is either true or false. So you can just access it directly var.variable name. And then we have number and string, which is also can be accessed directly, but it is for number, and string is for string. Okay, so that's it from this video perspective. Make sure you complete the exercise in the day 7 folder. There is a task.md. Complete that. Make sure you do the hands-on, otherwise you will forget everything that we have discussed and it will be of no use. So I hope you do that. I hope you try out it, and I hope you do the submission as well for the day 7. That's it for this one. I know it was a long video, but I hope it was valuable. So thank you so much. I will see you tomorrow with the next one. Thank you.